Lots of new discoveries from JWST, why Hakuto-R crashed, and Kepler's last exoplanets. All this and more in this week's Space Bites. I've heard that people would like to hear some more information from JWST. Well, here you go. We've got a ton of new interesting discoveries made by the James Webb Space Telescope. So first up, we got some amazing images of the plumes around Enceladus. And like normally JWST is spending its time looking out to the very edges of the observable universe, but it can still look here inside the solar system. And so they directed its gaze at Saturn's moon Enceladus. And of course, famously, this moon has plumes of water ice that are blasting out into space. It's one of the most interesting worlds in the solar system to explore because wherever you find water on Earth, you find life. So we know there's liquid water on Enceladus. We can see it being sprayed out into space. And so it's the perfect place to go and look for life. JWST was able to observe one of the largest plumes that's ever been seen. So when you consider the world itself is 505 kilometers across, but the plume extended about 10,000 kilometers away. They estimated that it's throwing out about 300 liters of water a second into space, which is enough to fill an Olympic-sized swimming pool every couple of hours. They did see water, but unfortunately they didn't see any other chemical constituents in the plumes. And this is important because we know from the flybys that Cassini did, it was able to detect dissolved hydrogen gas in the plumes, essentially food for bacteria. And the hope was that maybe JWST would also be able to see this hydrogen gas in the plumes, as well as maybe other organic molecules that could be more indicative that there's life there. So great analysis of the plumes. Didn't get all of the data that they were hoping for. We still are going to need that spacecraft to go and fly through the plumes of Enceladus to give us those answers, or to snake butt crawl around the surface, or descend down into one of the plumes to sample the ocean below. The other observation is of a fairly famous exoplanet known as WASP-18b. And astronomers have known about this planet since 2009. It's in the hot Jupiter class, but it orbits around a star that's a little hotter and brighter than our own sun. The planet has many times the mass of Jupiter, so it is nothing like the Earth, nothing even really like Jupiter. We don't have any analogs here in our own solar system. But the question that astronomers wanted to answer was, like, what happens to the atmosphere of a world that is this close to its star? What they did was they observed how the planet was passing in front of the star and then would pass behind the star. And they could measure the temperature of the planet where we were seeing the far side, the night side of the planet. But they could also observe as it was just starting to peek out from the other side of the star and see that it was quite hot and bright. And they were able to determine that yes, indeed, the planet is tidally locked to the star, and it ranges in temperature from the day side to the night side by about 1,000 degrees difference. They were able to measure the atmosphere of the planet. They found water vapor in the planet. Now, that doesn't make it habitable just because you've got water vapor. You know, steam is not very habitable, but it's still, they were able to see the temperature changes. And one of the big mysteries is, like, when you have this planet that is tidally locked, where one side is locked to the star and the other side is in internal darkness, how do the atmospheric systems move this heat around the planet? And what they found was not well, that they weren't finding the kinds of changes in temperature flows from the day side to the night side. Like, man, I'm like having trouble like wrapping my mind around this. Like it's so amazing that we've got these, not only just like we understand that this planet exists, that we understand that it goes around the star this closely, that it's probably tidally locked. No, now we measure the atmosphere. We can see the day side, the night side, and we can see how the heat is flowing around the planet. So cool. Not cool. Yeah, the opposite of cool. So hot. That's hot. Yeah. Now we know why Hakuto-R crashed. All right, last week I mentioned that Hakuto-R crashed, and we got some new images of the crash site thanks to NASA's Lunar Reconnaissance Orbiter. And you're able to blink back and forth between images to see the potential crash site. And just like a couple of hours after we released the episode, we got an explanation of why it probably crashed. And in fact, if you want to see another video on this, definitely check out Scott Manley's video. He goes into great detail and explains what happened. But the short version is that originally Hakuto was supposed to land on this open plain, a very flat landscape. And they changed the landing site to go inside a crater, and that required writing some new software for it to be able to analyze its surroundings. As it got closer and closer to the landing site, and as it passed the rim of the crater, its rangefinder got confused about where it was, and so it thought that it had actually landed when it was still about 5 kilometers altitude above the surface of the moon. It then continued to fire its thrusters, thinking that it was still sort of setting down gently on the surface of the moon, and then it ran out of propellant, and then it just free-falled for the rest of the way and crashed onto the surface. But apart from that, it was actually a very successful mission. Like, we got a private company was able to deliver a lunar lander very close to the lunar surface. All of the parts worked except for this last, I guess, the most important part. But hopefully this will set up iSpace for future missions to the moon, and we could see more and more commercial flights to the moon, delivering supplies, instruments, experiments. I like their chances for next time. And the next company that's going to try to land on the surface of the moon is going to be Astrobotics. They're going to be flying on the first test flight of United Launch Alliance's Vulcan rocket. So once again, we'll go through this whole process of waiting to see if a private lunar lander can set down safely on the surface of the moon. Good luck, Astrobotics. A record number of people in space. Isn't it amazing to think that there have been human beings in space flying overhead continuously since the launch of the International Space Station over 20 years ago? There has never not been people in space, but the number of people in space has increased and decreased depending on which missions, how many crews, whether they're swapping over crews. You had more people when there was the space shuttle flying and then delivering astronauts to the International Space Station. Now we have the Chinese space station, which has astronauts on board. Last week, we had this perfect moment where you had 3 crew members on the Chinese space station being swapped out with 3 other crew members on the Chinese space station. You also had 7 crew members of Expedition 69 on the International Space Station, 3 Russians, 3 Americans, and 1 astronaut from the United Arab Emirates. And then you had the 4 members of the Axiom 2 mission, which is this private mission on a Crew Dragon up to the International Space Station. So if you add all that up, you get to 17 people in space. But there's a bit of a hack. Just before the launch of the replacement astronauts for the Chinese space station, you got the launch of Unity 25 from Virgin Galactic, which had 6 people on board. So 14 plus 6, you got to 20 people who were in space, and then they landed, and then you got the launch of the Chinese, which brought the number back up to 17. So any way you count it, there are a lot of people in space, both through these handovers, but also just all the time now. Like, there's at least 10 people in space all the time now. Ingenuity went silent, but now it's back. Now, we've been raving about the successes of NASA's Mars Ingenuity helicopter for quite a while now. They just completed Flight 51, but a few weeks ago, things got a little scary. We got a recent blog post from the engineer of Ingenuity, Travis Brown, and he talked about how they lost contact with Ingenuity for about 6 days. So what happened was, overnight, Ingenuity ran out of power. And this happens a lot. Its solar panel is covered in dust. It has a hard time keeping itself completely warm during the long Martian night, and it runs completely out of power, and then it has to reset itself. During one of these resets, its clock became unsynced with the Perseverance rover clock, and so they weren't trying to communicate with each other at the same time. This has happened before, and so normally you just wait until they're able to restore communication. But there was a bit of an extra problem, which was that the landscape was not good for radio communication between Ingenuity and Perseverance. So there was some landforms in the way. The antenna that Perseverance uses to communicate with Ingenuity was on the wrong side of the rover. You know, it's like Wi-Fi in your house not communicating correctly. So they're able to work through all of these problems over the course of several days. And finally, after 6 days of blackout communications with Ingenuity, they were able to finally restore communication and learned a bunch of valuable life lessons about where you park your rover and your helicopter when you know you're going to run out of power on one of these Martian nights. And I feel like I keep saying this, but like prepare yourself emotionally that eventually there will be the final report from Ingenuity. Like it was supposed to only fly for 5 times. Now we're more than 50. This can't last forever. Make your peace. Kepler's last planets. NASA's Kepler Space Telescope was the most productive planet hunting mission that's ever been sent to space. It found 2,711 confirmed exoplanets and then another 2,056 candidates. But near the end of its mission, it was running out of fuel and it was becoming more and more erratic. It wasn't able to maintain a solid lock on its target for long enough time for the astronomers to get really good data. And so in the final observing run, mission number 19, astronomers were able to get partial data out of the telescope. And from that partial data, they were able to reconstruct and identify 3 final exoplanets. They had a bunch of amateurs look through the Kepler data and identify, even by eye, the dip where the planet was passing in front of the star. Now, the planets themselves are not that interesting. They're like a bunch of super Earths. Listen to me. Oh, boring exoplanets. I know there are no boring exoplanets. They're all awesome. But still, I didn't even learn them. But these will be the final planets that are in Kepler's data. Now, there might be other planets found with more weak signals earlier on in the data, but sort of chronologically, the last time Kepler was able to take pictures of the sky and discover planets, these are those. If you want to learn more about TESS, which is hunting planets right now, and hopefully will give Kepler a run for its money in the long term, you should listen to this interview I did with Dr. Nicole Colon from NASA. After Space Bites each week, we give you a chance to vote on the story that you found the best. And the one that was well ahead of all of the other ones was this idea that those impossible galaxies might be even more impossible than previously believed. I think we're working on a story that maybe they're not as impossible right now. So, as we flip back and forth week after week after week, but still, but that was the one everybody liked. So once again, right after we release this episode, we'll put up the vote. You can decide which of the stories you thought was the best, and we will tabulate that for next week. So make sure you're subscribed to the channel, and that way you won't miss these cool votes and see which of the stories did the best. A new way to search for habitable planets. Now, I'm sure you're familiar with the habitable zone. This is a region around a star where liquid water can exist on a planet. Not that it does exist, just that it can exist. So like closer into the habitable zone, water is boiling. Beyond the habitable zone, water is freezing, but in between you can have liquid water on the surface of a planet. But life, as we know it, requires water, but it also requires carbon. And it turns out when you look at the Earth and you think about all of the life that's on the surface of our planet, Earth is considered water poor and carbon poor. And that's because Earth didn't form with its water in place. It would have all boiled away. Instead, the water was delivered later on, maybe by dust, maybe by comets, asteroids, some way to get the water. When you compare that to places like Europa, Enceladus, these ice worlds out there, they're almost entirely water. And Earth is carbon poor, which means that we also didn't have a lot of this carbon formed locally with Earth. Maybe we had that delivered later on. And so astronomers are starting to wonder, is there a carbon zone that's part of the habitable zone? Is there a soot zone? You sort of think about like what would be on the inside of your chimney, this sort of gunk, these carbon molecules that are inside your chimney. And in fact, the levels of carbon would have an influence on the formation of life and interact with the amount of water that you could get. And in fact, you could get a region that is outside the habitable zone for water, but if it was a world that had a lot of carbon on it, maybe that would increase its habitability farther away, maybe all the way out to the frost line of a star system. And so astronomers are identifying planets that might be high in carbon. There's actually one they know of called 55 Cancri E that appears to be 1/3 carbon. So we have this just thin veneer of carbon on the surface of Earth, but there could be worlds out there that are largely carbon. What would that do for life? Now, if you noticed, we don't have any ads in the middle of this video. We don't have any sponsorship messages in this video at all. And we like that. I know they can be very long, they can be very disruptive, and they just decrease the quality of the video itself. And so we try to make this as useful and science-focused as we can. And instead, we fund the work that we do through our patrons. And this allows us not only to release this material out as publicly as possible. We don't put anything behind paywalls. We release everything as a Creative Commons 4.0 license so people can reuse it, remix it, do whatever they want. And that's all funded thanks to our patrons. Most of the other channels in this space, they have to do sponsorships, and we could make more money if we did sponsorships, but I just don't want to. And it makes a better quality video, and I hope you appreciate that as well. So if you want to be a part of this amazing community, go to patreon.com/universetoday. Help us stay independent and as ad-free as humanly possible. LIGO is fully operational again. Have you noticed that we haven't talked a lot about gravitational wave discoveries recently? That's because the world's giant gravitational wave observatory telescopes are offline. They are being upgraded and improved. And in fact, just last week, LIGO came back online with a ton of new improvements. There's a laundry list of changes and fixes they made in improving the various instruments on board. But one of the big changes that they made is called quantum squeezing. And there's like a longer version of this explanation, and I'm going to give you the short version, but essentially they take advantage of Heisenberg's uncertainty principle. Like, there is a limit to the amount of information that you can gather about photons or particles. But if you're willing to sacrifice one part of the observations, you can greatly increase the sensitivity on the other side of it. And that's what they're able to do. They call it quantum squeezing, but essentially they're saying, we don't need this part of the uncertainty, which will give us more certainty in this area, and that allows them to make much higher resolution scans of the gravitational waves that pass by. So these upgrades double the sensitivity of LIGO, which means that it can sense gravitational wave events in a much wider sphere, as well as new kinds of events that have never been seen before, like merging white dwarfs together, or a white dwarf and a neutron star, or stars at vastly different masses coming together, and just more gravitational wave events overall. And so I wouldn't be surprised if upcoming episodes of Space Bites just turn into like, here's all the JWST stuff, and then here's all the LIGO stuff every week. And then, of course, we're going to get 2 more gravitational wave observatories coming back online as well. Virgo got a series of upgrades, and then the Japanese Kagra Observatory is going to come online as well. So you've got 3 different observatories located around the world working together to observe gravitational waves. So we are just really in the era of gravitational wave astronomy now. To wrap this up, we've got some cool new pictures of space. Well, hot, really. The first image is fire in space, but this isn't regular fire. This is iron on fire. So the European Space Agency recently tested on a suborbital rocket how iron particles catch on fire in space. Now, you've probably seen experiments where you can light, say, steel wool on fire, and so metal burns. And there's like an optimal way to make metal burn, depending on how far away the particles are from each other, how the heat from one particle is able to leap to the next one and ignite it and keep going. And when you're in weightlessness, you can sort of have the particles hit the exact right distance and shape to each other to be able to find out what is the optimal way to burn iron. And I'm sure you're wondering, like, why do you want to light iron on fire? What's that about? Well, if you light iron on fire, you generate a lot of heat. And the byproduct of that is iron oxide. It's rust, and you can then use hydrogen to restore the iron and then use it for fire again. And this whole process generates no carbon dioxide. There's no carbon involved in the process at all. And so we could see future furnaces, power plants that run on iron and not fossil fuels, and you still are able to generate the same amount of electricity. There's a prototype that they built that fits within a warehouse and can produce a megawatt of power purely by burning iron. And so we could see this technology find its way into a lot of prototype and new startups that focus on iron-fired power plants as opposed to coal or oil or gas. The other image, also hot, comes from both the Chandra X-ray Observatory and JWST. And in this, you're seeing the combined light of these two observatories merge together. And the two observatories are on the opposite sides of the electromagnetic spectrum. On the one hand, you've got JWST, which is doing infrared, cooler objects, star-forming regions, clouds of gas and dust. And then on the other side, you've got Chandra, which is looking at X-ray radiation coming from stars, the regions around supermassive black holes, quasars, whatever's at the extreme hot side of the cosmos. And so when you blend these two images together, you can see the star forming regions, the cooler gas and dust, but also the young new stars that are blazing inside of it. You can see the centers of galaxies, which are surrounded by all this gas and dust, but also the hot quasar at the middle, which is blasting out X-ray radiation. I love it when they merge the data from different telescopes together to get these kinds of combined images. And this has been done a lot in the past. You can see images coming from Spitzer and Hubble and Chandra all mashed together into one image. All right, those were all the news stories that we had today. Of course, we're going to have links in the show notes down below to everything that we talked about, so you can just keep researching. You can get even more space news in my weekly email newsletter. I send it out every Friday to more than 60,000 people. I read every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent and keeps ads at a bare minimum. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Just Paul Davis, Vlad Shipolin, Jay Dennis, David Giltanen, Modso, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verbeoff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. All right, that was all the news for today. We'll see you next week. Big week.